Hi everyone, my name is Sheikh Sirajuddin, going to explain about classification of magnetic materials. The magnetic materials are classified into three types. These are diamagnetic, paramagnetic, and ferromagnetic materials. The first one is diamagnetic materials. The magnetic materials which acquire feeble magnetism in the opposite direction of applied magnetic field when placed in external magnetic field. Such materials are known as diamagnetic materials. The examples of these materials are inert gases, helium, neon, etc. Metals like copper, zinc, gold and silver, mercury, glass, water, marbles, etc. Properties. Due to different orientation of electronic orbit in an atom of diamagnetic materials, the resultant magnetic moment is zero. These materials do not possess permanent dipoles. No spin alignment is present in this material. Susceptibility is negative. Relative permeability is less than 1, i.e. nu r is equal to 1, nu r is less than 1. Diamagnetic materials are temperature independent. In the presence of magnetic field, the magnetic force of line push out from the material. This magnetic flux density inside the specimen is less than flux density free. The materials which acquire feeble magnetism in opposite direction of applied magnetic field when placed in external magnetic field, such materials are called as paramagnetic materials. The examples of these materials are oxygen, platinum, sodium, potassium, alkali metals, etc. Properties. When these materials are placed in external magnetic field, the net magnetism will be induced since the magnetic moment in the direction, hence there is no magnetic moment along the field direction. These materials possess permanent dipoles. The spin alignment is at random. You can see here the spin alignment is random. The susceptibility is small and positive. Relative permeability is greater than 1. These materials are temperature dependent. In the presence of magnetic field, the force lines passed from material, then magnetic flux density in the specimen is greater than flux density in the free space, i.e. B in greater than B out. Now the next type of magnetic materials are ferromagnetic materials. The materials which are strongly magnetized in the same direction of applied magnetic field when placed in external magnetic field, such materials are known as ferromagnetic materials. The examples of these materials are iron, cobalt, nickel, etc. Properties. Ferromagnetic materials possess permanent magnetic moment even in the absence of external magnetic field. The materials induce magnetic moment produced during application of external magnetic field, which is very large, and it increases the magnetic induction in the specimen. All spins are aligned in parallel in the same direction in the domain. Susceptibility is positive and high. Relative permeability is greater than 1. Susceptibility depends on temperature. When the temperature is increased, ferromagnetic materials convert into paramagnetic materials. In the absence of magnetic field, the magnetic lines of force are passed through the material, then the magnetic flux density inside the specimen is greater than the flux density of the free space. Therefore, B in far greater than B out. These materials exhibit magnetism even in the magnetism field is removed, they exhibit hysteresis. And finally, these materials consist of small magnetic regions called as domains. So ferromagnetic materials are further classified into two types. These are antiferromagnetic materials and ferric magnetic materials. The first one is antiferromagnetic materials. In antiferromagnetic materials, the spins are aligned anti-parallel to each other and having equal magnitude so that the net magnetism is zero. This type of magnetism is known as antiferromagnetic materials. Examples of these are FeO, MnO, Cr2O3, and salts of transition element, etc. The properties of antiferromagnetic materials are the spin alignment is anti-parallel in domain, the susceptibility is small and positive, the temperature at which the antiferromagnetic materials convert to paramagnetic materials, the temperature is known as Nernst temperature. Susceptibility is inversely proportional to temperature. The next one is ferric magnetic materials. In ferromagnetic materials, the spins are aligned anti-parallel to each other and having unequal magnitude so that the net magnitude is not equal to zero. This type of magnetic materials is known as ferrimagnetism. The examples of these ferric magnetic materials is ZnFe2O4, nickel ferrite, ceramic materials, etc. The properties of these materials are spins are aligned anti-parallel in the domain, susceptibility is positive and high. The temperature at which the magnetic materials convert into paramagnetic materials is known as Nernst temperature. Susceptibility is inversely proportional to temperature. Ferrites are best examples for ferric magnetic materials. So these are all the classification of magnetic materials. These are mainly three types, which are paramagnetic, diamagnetic, and ferromagnetic. Thank you.